What happens when we create machines that are as or more intelligent than we are? What are the possible timelines, implications, and ways forward to ensure we create the most positive future for our world? In this first episode sequence on timelines, we're looking at how these machines might be built and when that might happen. In later episodes, we'll dig more deeply into the implications of AGI and how we can ensure they benefit our world. This is the AGI show, and I'm your host, Sarush Paul. Today I'm here with Ryan. Pleasure to meet you, Ryan, and great to have you on the show, Ryan.
Great to be here, Sarush. Happy to talk.
Fantastic. Fantastic. So Ryan Kupyn, he's a data scientist and professional forecasting researcher currently working at Amazon. I actually got in contact with Ryan because he was the number one forecaster on a 2022 prediction contest hosted by a very popular Tech Insider newsletter that many of our listeners may have heard about. It's called Astral Codex 10. So this prediction contest asked cut and dry questions, things that you could say yes or no, did they happen, did they not? Things like, will Joe Biden's approval rating be greater than 50% by the end of 2022? So those kinds of questions. And they asked questions on everything from US politics to the war in Ukraine and much else. So Ryan not only won that contest out of the 500 plus participants who went into that contest, and obviously these participants they like their forecasting, so they're not your average Joe. Many of them are professional forecasters themselves. So Ryan not only beat that cohort and came first in that contest, he also beat out the group other people who are considered super forecasters, and I'll describe a little bit more what that is shortly. He beat out the wisdom of the crowd, so he beat out the average of everybody in that forecasting contest. He beat out the wisdom of the super forecasters, so the aggregate of all the super forecasters in that prediction contest, Ryan still beat out. And he even beat out prediction markets, so markets designed to predict events and trade on them. These are some of the best vehicles we know of for forecasting, and Ryan's prediction beat those as well. So, of course, there's luck and chance involved, but I am confident, having dug into the prediction contest, that it's not just luck that describes and explains Ryan's fantastic performance. And it's also not an accident that he's a professional forecaster who happened to come first in this contest for one of the most successful technology organizations around the world, Amazon. So we mentioned the term super forecaster a few times. So super forecaster is a term from a book, Super Forecasting, by Professor Philip Tetlock at the University of Pennsylvania and Dan Gardner. And this book was a bestseller, and it showed the ways which practiced forecasting skill could outperform even subject matter experts. So, quoting Tetlock, the author of this book, when they looked at a prediction around how intelligence agencies do versus some of these forecasters, he actually found that the top forecasters, these super forecasters, performed 30% better than the average for intelligence community analysts who could read intercepts and other secret data. So that's a pretty crazy concept. So there was an intelligence community. These people are subject matter experts. They've got access to secret, non public information, and yet they underperformed these super forecasters, people who had practiced and refined the skill of forecasting itself. So this really is demonstrative of how much value there can be from taking time to kind of train yourself up as a forecaster. Ryan is one of those people. So Ryan is a professional forecaster, and as he's shown in the 2022 prediction contest, he is a fantastic forecaster himself. And I'm very excited now to have him here with us on the show to talk through AI timelines and AGI timelines and to apply all his skills and knowledge to that domain. So great to have you on the show, Ryan, and really excited to get your skills towards this question of AGI.
Thanks for that intro, Sarush. Great to be here. Happy to talk about this, and I love sort of talking about AI, learning about it, and sort of sharing my knowledge with folks.
Fantastic, fantastic. Ryan, just give me half a second. I'm just
No
gonna.
worries.
I realize my screen setup isn't the best for looking at the questions and looking at you, so I'm just fixing that, and we'll cut this part out.
You get to be like judge, jury, and executioner of this podcast, editing and controlling questions. It must be fun, but I imagine it's a lot of work.
It is fun. It is fun. It's an amount of work, but I really enjoy it, so it doesn't
Yes,
feel too much like work. Awesome. Okay, so we'll get into the questions. Okay, Ryan. I know you had a note for our listeners that you wanted to share about just kind of your affiliation with Amazon. So do you want to talk about that?
totally. I'm just going to note that the views I'm talking about here, expressing here, represent my own personal views and don't represent the views of Amazon or AWS forecasting.
Fantastic. Yep, definitely. Fantastic, Ryan. Well, why don't we just start off with, I definitely tried to give an intro and hopefully I captured everything accurately, but it's always good to hear from the person themselves. Tell us a little bit about yourself and what you do in your profession as a forecaster.
Totally. So, as George mentioned, I'm Ryan. I live in Los Angeles, and I currently work for Amazon, where I work for AWS forecasting. And there, basically, I'm generating forecasts that ultimately drive a lot of Amazon's capital expenditures and server ordering and things like that. And in my current job, I do essentially forecasting research where I'm doing data science work that is designed to improve how our forecasts work in production. My background is in sort of statistics, where I worked on a bunch of different sort of forecasting related and a little bit of AI, ML, generative AI projects. And before I joined Amazon, actually, I had a somewhat more qualitative forecasting job where I was doing legal advisory for companies that were facing like lawsuits, trying to advise them on how to most efficiently settle a lawsuit, which basically involves trying to figure out and forecast the sort of outcomes of a lawsuit if it were to go to trial, and then figure out what a good strategy is responding to that. And that's really
Wow.
my background in a couple sentences.
Wow. Well, that's fantastic. I mean, it's great to hear that you've got some of the background in AI ML as well, so you can speak more specifically to some of the internals. And the lawsuit one is a fascinating one. I'm sure we could do a whole podcast episode on just that topic, but I'll hold my curiosity for the sake of our listeners. We'll dig more into the AI side of things today.
Absolutely.
Yeah. Fantastic. So I do think it's actually valuable. So many people listening to this podcast, excuse me, are thinking about forecasting. Thinking about what's going to on in the future and how do I think about that. So, given your skills and expertise, I actually think it would be interesting to dig into the art of forecasting itself. So, when you think about forecasting, um, what do you think are some of the ways to be good at forecasting, some of the best practices, and what are also some of the gotchas that people make mistakes on and therefore introduce errors into their forecast? What are some of the best practices here?
Absolutely. Now, when I think about forecasting problems, I really envision two basic types of forecasting problems, or these are really two different approaches. Because sometimes when people ask me to forecast something, like say they're asking me to forecast whether Joe Biden will still be president in a year, you can either look at what other experts are saying and try to figure out which experts are most reliable historically and then go with their predictions, or you can try to model the underlying dynamics explicitly. Now, these approaches both have trade offs. Sometimes in certain forecasting domains, you have experts who really are very good at forecasting, and the challenge is basically just picking out that signal from the noise. Other times,
Hmm.
the challenge is that there aren't really any good experts, and you need to figure out what the actual dynamic driving a particular the phenomenon you're forecasting is. And you can sort of split this up into a couple different approaches. Like, for instance, Nate Silver, he in his political forecasting really adopts the second approach, where there is a genuine um, sort of signal out there in the form of
Mm.
polls about what people
Mm.
are saying, and the question is like how effectively can we figure out what people's actual preferences is. The alternative version of this is, say, if you asked a bunch of pundits um, who they thought was going to win the next election, and said, okay, we're going to use the best pundits historically, and that approach sort of underperforms the sort of poll-driven approach for a couple different cycles, and that's really the way I think about the way I divide up the forecasts that I produce. Now, the most
Fascinating.
common pitfall that people make when forecasting is they're too overconfident in their model, basically. Obviously, if you're looking at different inputs, these inputs may have only weak correlation with what you're forecasting. Like a good example is
Mm.
people might have a sort of economically driven uh, election forecast where they say, okay, if
Right.
economic
If
fundamentals are bad, incumbents are going to lose. If they're good, incumbents are going to win. But this often has sort of shortcomings. It can underperform, and people are often overconfident in practice. They don't really appreciate their limited ability to say backtest this or the different domain changes that can occur. And that's really the fundamental pitfall that I try to caution new forecasters against. Really making sure you're modeling both the expected outcome but the uncertainty around that outcome, and you're really
mm.
aware of this situations which you could be wrong, basically.
Got it, got it, got it. I mean, if I had to take a one line takeaway from that, it's don't be overconfident in your forecast, and that in and of itself, or the models that you use to develop that forecast, which is an important fact that I think many people do lose in the art of in when they do start to make predictions about the future.
Absolutely. And I think there are certainly ways for people to get around this. People can go out
Mm.
and try and disprove themselves, or literally, you can go out and find the people who disagree with you in terms of the outcome and ask them, what are you looking at that's leading you to a different outcome than I am? And sometimes that's very hard, even for me to do from an ego point of view, to go and engage very directly with the assumption that I might be wrong. But it's really a skill that I think is very valuable to develop as a forecaster.
Right. So not only be, step one, be humble in your prediction, and step two, get alternate views and critique of that in a way that possibly will add new information or perspectives or data to kind of refine the forecast.
Exactly. Um, and it's always an iterative process. Like I started out honestly as a not very good forecaster, and it's taken a lot of work and a lot of sort of self-criticism to get to the point where I am able to forecast things moderately effectively in general.
Can you touch on that just a little bit? What does training to be a forecaster look like? What are some of the kinds of things that you do?
I think that trading really is just on an individual level, making a lot of forecasts, checking to see if you're wrong, and if you're wrong, asking yourself, why did I get this wrong? Like at the start of COVID, obviously,
Mm.
I was very concerned, and my forecasts had a lot of personal relevance where I was trying to figure like what is the actual risk if I go outside that I'll get COVID, and how can I minimize that risk?
Mm.
And I would make a certain decision about how to minimize that risk. I'd say, okay, I'm going to go for a walk, or I'm going to go hang out on my friend's balcony, but I won't go in a grocery store. And then I would basically go home. And of course, during COVID, people had a lot of time at home. And I would go home and I'd read all these scientific papers and I'd say, okay, is my mental model of what COVID risk is like mapping well to the actual scientific data that's coming out? And
Right, the
how should I
data
adjust
that's
that mental
coming.
model?
Yeah.
Exactly. And this sort of general approach maps pretty well like to other domains. Like I do a little bit of trading on the side, and a lot of times I will look at a narrative that's sort of arisen around a stock or a different sort of financial instrument. Like a couple of years ago, I was really interested in trading volatility, which was a sort of traded note on the market. And I would basically
Mm.
read news articles about people who were trading this. And I'd say, are these people right? And if I was sure that they weren't right, I'd go make a bet against them and see what happens. And when you lose money, you're like, okay, I was wrong about that. And why was that the
Yeah, yeah,
case? And it's really just an iterative process. Of course, when
yeah.
I'm doing this professionally, you're operationalizing it differently and you're trying to build a system that can do that process, that can um, take data and correct itself statistically. Um, but the same general approach applies.
Fascinating. I guess yeah, markets are a good place to train your hand in the sense that you have a very clear signal. If your prediction is will this price go up or down, or some other indicator like that, you can very quickly go see after the fact if you're right or wrong.
Exactly. I think that the worst forecasts are ones where you're able, or where I'm able to pretend that I was right all along. And markets do provide that sort of very quantitative feedback that is
Yeah.
really valuable for refining your skills.
I also wonder how, and I'm sure I'm guilty of this too, so it's not a judgment on anyone, but also forgetting your losses, that sort of logic as
Hmm.
well. You make these predictions, you don't remember all the ones where you turned out to be wrong. You just remember that one time you really nailed it.
Yeah, I mean, I have sort of a morbid interest in people's mistakes, particularly in the forecasting realm. Like understanding how people can make decisions that are wrong is really interesting to me. And being aware of the times that I've been wrong before is
Mm.
has been super valuable in my development as a forecaster.
That's awesome. Yeah, I actually, as part of this thinking on AGI, I saw a blog post or article about the worst tech predictions ever. Because we often
Mhm.
talk about all the best predictions, but we don't often talk about the worst. And there was a long list of interesting stuff. They named number one worst tech prediction was, and this was obviously a subjective rating, but their worst number one worst prediction was Steve Ballmer, and I think it was the iPhone. He was talking about, you know, this isn't going to win. This is problematic in these ways, and obviously the iPhone has turned out to be the one of the most successful products in human history. So,
Yeah, so one thing I'll add to that is
mm,
that when you're looking at other forecasters, it's often
mm,
important to understand why they're generating that forecast. And if
mm,
you're Steve Ballmer and it's 2007, you've invested a lot of money in sort of the pre-existing infrastructure of Windows and Office. And the iPhone is, and was at the time, really a threat to that. And you can understand why Steve Ballmer gets up on stage to all their employees. He needs to tell them something that's going to keep these employees motivated and keep them from
right.
leaving to Apple. And sometimes being able to understand why someone else is making a forecast is as valuable as actually making a forecast yourself because it gives you insight into their motivations.
Yep. Yeah, and you're absolutely right. And I think that's a really good example of what maybe even in his heart of hearts or in private conversation he had different predictions, but it's a different thing to be making a quote unquote prediction in the context of inspiring employees or having any other kind of intention. You have an intention. It's not just about predicting correctly. It could have other intentions in there as well.
Mhm. Absolutely. And certainly the
And
yeah.
credit to Steve Ballmer. I actually remembered a little bit more of the detail of that prediction. His prediction wasn't specifically maybe that the iPhone was going to fail. It was more about who would capture the value from that. And I think his argument was, as long as there's phones and as long as we can sell software to those phones, then we will be okay. It didn't exactly play out that way because Apple did end up capturing a lot of value. But there was a bit more nuance to that prediction that was rated the number one worst prediction by this particular blog post.
Absolutely.
Yeah. So I want to dig into one specific aspect of good forecasting, which is around subject matter expertise. I think it is quite, and I've been thinking about this a lot in the context of AGI timelines and who to bring onto the show and these things. I think there's a natural tendency for us to believe as people that subject matter experts, people who know a domain particularly well, are the best people to ask about a problem. So, for example, if you want to know who's going to win an election, ask the person who's read the most on elections. If you want to ask, or maybe a politician themselves if they don't have other competing intentions. If you want to ask about AGI futures, ask the people working on AGI and building AGI. Um, in your experience, does subject matter expertise lead to better predictions? And yeah, what are the how true is that common wisdom that subject matter experts are good people to ask about forecasts?
I think subject matter experts are actually valuable inputs to a forecast, but sometimes what people do is they'll ask a subject matter expert to make a forecast that they're not necessarily skilled at, rather than trying to use them as a source of facts and in data for a broader forecast. One example is when I was working advising in lawsuits. um, I would work with lawyers, and the lawyers, of course, were subject matter experts in their field. Say I was working on
Yes.
a labor discrimination lawsuit, and I'm trying to figure out if this lawsuit goes to trial, um, what kind of damages do we expect? Obviously, from a total outsider's perspective, this is something that's really hard to figure out. But lawyers, I'd ask them, okay, how are damages usually calculated? What sort of arguments and set of facts are believable or persuasive to these
Mm,
judges, or
mm,
this judge in particular? And I could use that as a input on the data side to my own model. But at the same time, if I'd asked the subject matter expert what the actual what damages would be if that case went to trial, that would be something that they wouldn't be skilled at. So I think that often when you're looking at subject matter experts making forecasts in the media, for instance, what happens is a journalist who knows very little calls up an expert and says, "What's your forecast?" Subject matter expert, of course, wants to be helpful. They give out a
name a
number,
number.
or
Yep.
and that is the number that you go with, and it makes it seem less helpful because you're not really don't have really the supporting infrastructure of an actual forecast around that. But actually, I find that to be very useful in generating my own forecasts.
Got it. Got it. So the knowledge that subject matter experts hold is important to a good forecast. You don't want to operate without that knowledge in some way capturing that knowledge. How would you then think about their actual forecast themselves? Would you take the forecast of subject matter, and I mean in the average sense, not in, I'm sure there are some people out there who would be better than others, but would you take the average subject matter expert's forecast at face value? And if not, how do you then use that in a broader context of a forecasting model?
I think that if I'm given a forecaster's own or a subject matter expert's own forecast, the way I'd approach it is trying to dig into what's the model that they're using
Mm,
that's driving their forecast.
mm,
Because often, in a forecast, there's an implicit model of what the underlying dynamics and constraints are in the subject you're forecasting. Like, say, you have someone who you're asking, can you help me predict the GDP of Nigeria in 2045?
mhm,
And
mhm,
say this person's an economist, someone who might plausibly be a pretty good subject matter expert here.
mhm,
And you sit down and you talk to them, um, and they say, okay, I think that in 2045, Nigeria is going to have a GDP that's 200% what it is today. And then I might ask them, like, what do you think is going to change in Nigeria over this time period? Or what do you think is driving this? And they might
mhm,
say,
mhm,
okay, population is going to increase by X percent. You have sort of capital accumulation and technological diffusion that's driving a part of this. And
mm,
my response here is try to understand their model in more explicit terms, and then understand what might be a shortcoming of this model. Like,
mm,
we might ask about GDP and say they have this model that's very population and technology driven. Well, you have other aspects of GDP that relate to GDP, like the price of natural resources. I know Nigeria has a very oil driven economy. Maybe those are better comparators. Looking at a country like Saudi Arabia or Norway or Venezuela, understand what's similar and different. And I think that the tricky thing about being a forecaster and
mm,
working with subject matter experts is everyone has their internal mental model, or they could have an actual written down model, if depending on what you're asking them about. And getting to the point of understanding that underlying model, if you want to create your own forecast, is very valuable. Of course, as I mentioned earlier, sometimes you can just grab a panel of forecasters, figure out who's consistently more or less accurate, and go with their
mm,
forecasts. That's pretty easy to do sometimes,
right.
and and has a much sort of much higher return on investment than trying to do all that work yourself.
Sure. And I want to ask something specific. You mentioned a lot about, so that makes a lot of sense. You want to dig in and understand how they're coming up with that forecast and be able to kind of look at that a bit more closely. In some domains like technology, I think these models do exist, like things like let's put together, sorry, and I guess with the use of models, some people, when they use the word model, they're talking about a mathematical type model,
Hmm.
something where they've got a spreadsheet or something else where they're putting in numbers and trying to derive something at the end. And there are those kind of things, and some people consider that to be more rigorous, certainly more uh, able to be looked into by others, but some people believe it's more rigorous because it's in mathematical quantitative terms. But actually, in a lot of cases, what people are doing are intuitive
Hmm.
models, right? So things that are only captured in their own mind in the final model itself. Um, what are your thoughts on models that are more mental models, intuitive models versus ones that are quantitative? Are they still useful and can they be sometimes even better than the quantitative models?
Oh, yeah, actually, qualitative models can be really important for a lot of things that aren't really well modeled. Can't really be
Mm,
really represented quantitatively. Like, probably the biggest, I'd say the most impactful event in 2022 was Russia invading Ukraine.
hmm.
And I can remember back in early 2022, I was thinking about this, and I'm actually of Ukrainian descent, so I was pretty
Oh wow.
invested in this. And
Hmm.
I knew other people who had family in Ukraine, and I'd read up on Ukrainian and Russian history. And I'd also been talking to a friend who was a professor of international relations who was talking about conflict and the power dynamics there.
Hmm.
And part of the reason I was able to outperform in this contest is I thought that Russia had to invade now because of the relative power imbalances were changing and it'd be
Mm,
increasingly less favorable, and that this would have a lot of impact on other things like inflation, like the macroeconomy more broadly, that weren't being accounted for in people's models. The downside of these qualitative approaches is that they don't scale really well. Like,
mm,
I can have a qualitative approach to Russia invading Ukraine, but it's hard to have a purely intuitive um, approach to, say, predicting the stock market, where I look at a bunch of, say, stock charts and I try to interpret
mm.
different patterns. The other thing that's really tough about these models, and why I generally try to stay away from them, is that I feel like the human mind is really good at picking up patterns that maybe
Mm.
aren't really there,
Sure.
and it's really easy to have an intuitive model that's overconfident, and you end up taking actions that don't protect you against the downside risk, even if your model is accurate in sort of expected value terms.
Yeah, fascinating, fascinating. So yeah, so I think it seems that they do have a value and they can often be very good, even maybe the best model, but of course they have their downside, scalability being one, and also they're subject to human failure modes, a different kind of set of failure modes, the quantitative kind. So that's really really interesting. I'm going to pause there on digging into the world of forecasting because again, I think we could have a whole podcast on that. And let's move over specifically into AGI. Um, Maybe let's start off with um, let's just touch on quickly what's your exposure to the world of AI and AGI? How much time have you spent thinking about this? Yeah, before we dig into maybe the specifics of your kind of your future predictions.
Absolutely. So obviously, AI has been in the news a lot lately, and I read the news
Hmm.
just like anyone else. So I
Hmm.
end up thinking about it that way. I've actually been not involved that much, but I do have some experience actually implementing sort of AI solutions in my old job. Of course, we would sort of implement naive but Bayes classifiers to try and solve a problem, which is just a very, very simple approach to, say, doing text classification, things like that. Um, And in my current job, we do think about things like AI in terms of how it will change demand for um, compute capacity over time and what the mix of compute
Oh, of
capacity is going
course,
to
yeah.
be over
The
time. Yeah.
relevance for Amazon for AWS are huge, aren't they? I never
Oh
even
yes.
I didn't connect that until just this moment.
Oh yes, absolutely. And unfortunately, I can't talk too much about that,
Yes,
except of
yes, yes.
course
Please don't.
we
Please
provide.
don't. Yeah.
Yeah, we provide a lot of AI services, and we are certainly thinking about what the future is going to look like in that regard.
Yeah, makes sense. Makes sense. Got it. So you've had exposure as a citizen who just is wants to be well read and thinking about these things. You've obviously know the world of statistics, and you mentioned earlier that you've even done some things in early days around kind of generative AI type systems a while ago. Um, have you played with ChatGPT and
Oh yeah,
DALL-E and all these things? Okay, so
I of course I play with them all the.
you've
Yeah,
tinkered as well.
yeah, and certainly as part of my work, I'm always trying to figure out ways to incorporate statistical and AI systems into business processes in a way that is, I want to say, rigorous and also effective. So certainly working at Amazon, it's a place that invites a lot of experimentation. So I've been able to do a lot of experimentation on that. Of course, the big discussion in AI these days is in very general models.
Hmm.
And I can
Hmm.
talk more about what I think the trade-off is between generalized versus domain specific models and how that affects the economics of rolling out these models in the actual uh, in in the broader economy in the future.
Yeah. So yeah, so I think yeah, I think it's time to dig into that. So, for our listeners, what they are most interested in is these general AI systems or some version of those things uh, improving and growing over time. So what they're really interested in is it possible for us to get human level AI? And if so, when will that happen? So um, maybe let's just ask that question. Do you think on some time scale, artificial general intelligence, so human level capabilities, is possible? And then maybe talk a little bit about how you see things evolving from where we are today to that possible future.
Absolutely. I'd say sort of putting my staking my position right here, we will reach a point at some point in the future, and I can talk about that in more detail a bit later
Hmm.
on, where you do have AGI, and I actually look back at Nick Bostrom's superintelligence to try and get a good operationalized definition here. And when I talk about that, say a single model system that's able to be better than most humans for most human professions. So,
Right.
certainly, I think that there will, for a long time, be at least niches where humans outperform AI systems. And I think that a
Right.
lot of this is going to be driven by the availability of training data that
Hmm. Hmm.
improves AI's world models. Um, but I think that there will be a point where, if you look at the set of human professions that exist today, AIs do better on intellectual tasks than most humans that are doing those professions right now.
Yeah, yeah, and to be clear, I completely agree. I haven't actually spoken a lot about why this is possible and if it's possible because I take that as an assumption. But for a lot of very good reasons, I think there is very little reason to believe it won't happen. Intelligence is made of atoms processing information. We're getting better and better at that. We don't believe there's something unique, so unique about the human brain that it can never be replicated in other substrates. And there's a lot of good reason to believe we will get there. So that's my position as well. Ryan, then maybe let's start to talk about from where we are today to that future world where we have AGI, how do you think we'll evolve and get there? And feel free to use timelines or ways of thinking about the timelines if that's helpful along the way as well.
Totally. I think that right now, when I look at the AI world, there are sort of two broad strands of effort and research and product development that are happening. You have, on the one hand, these somewhat generalizable large language models, of course, pretty much all your readers will be very familiar with them, things like GPT. Um, and then on the other side, there are relatively simpler models that take a sort of narrowly curated subset of training data. Maybe you have a specific objective function, and then you try to create a model that does one relatively small set of tasks very effectively. I actually have a little bit of experience training that for like image classification in my old job, where we were trying to identify people doing a small set of one of six tasks in images
Mm.
to try and provide input in a labor lawsuit, which involved people doing those tasks. So you had security camera footage, and you'd basically spin up an image classifier for six different categories. And the advantage of those is that they're not very compute intensive relative to
Yep.
the more general models. The advantage of the
Yep.
general models, of course, is you have a very broad set of tasks that these can do. But at the same time, you have a couple problems, or a
Hmm.
couple challenges. First is the general models often do not perform quite as well as a specialist model that is trained on that same task for a given amount of effort put into creating it.
Mm. Sure.
Second, I think that in my experience, these generalist models are often really hard to debug, and I think that a lot of businesses are a little bit averse to putting them into production where you can have a lot of unexpected behavior. Like just today, looking at people playing with Bing, playing with ChatGPT, getting a lot of unexpected behavior, I think would give people, well, if you're someone who's putting these into production where they're, say, customer facing, it can be really tricky to make that decision. And I
Yep.
sort of oh, see these
No,
trends
no, no. I
continue
was
to.
gonna say
Oh,
the second one, absolutely, I agree. The first one, I think there's some room for kind of
mhm,
debate, or it really depends on maybe the specifics. But the second one around, are they ready for go time? In a lot of cases, is certainly not without lots of kind of barriers, and then that then makes questions about, well, how many humans do you need still involved, and these kinds of questions. So yeah, there's definitely
yeah,
challenges with the present models today.
yeah. And I will sort of go beyond this and say that in my mental model of what's driving these progress forward in these areas, there are really three constraints.
Mm.
The first constraint is both of these models, or all these models, need people who have expertise creating them. Your ML engineers and
Yep.
research scientists who work
Yep.
on these models. Right now, that skill set is pretty scarce. The second constraint is you need a lot of capital to acquire the hardware to train these models. I think GPT-3 certainly cost at least a couple $1 million to train. I don't have an exact number. I don't think
Yeah,
anyone
I
in
don't
the
I
public
don't have
domain
an exact
does.
number, but it's if you include lots of failed attempts, I'm sure it's well in the millions, if not tens of millions.
Absolutely. And I think the third constraint that's not necessarily discussed too much, or could be discussed more, is the training data. And
Hmm.
depending
Hmm.
on what you're doing, you can have a reinforcement learning model where you say have your simulated Go game is playing against itself, generating training data that way. Or in a lot of these large language models, you end up scraping the web. For generative image models, you end up scraping a corpus of images. And I think that actually one of the biggest sources of variance in AI progress is whether the legality of using this data is going to change in the
Mm.
future. Because
Right.
just recently you've had lawsuits against Stable Diffusion by Getty Images claiming that they're using their data illegally. And of
Right.
course, because the people doing this AI training are not folks sort of out in their home offices, their large corporations, I think that there's some sensitivity to the precise legal status of this AI training data, which might
Yeah.
affect future progress.
Yep, definitely. And so I think all of this makes sense. So there's essentially some potential pitfalls in the growth and development of these models, that people may not be accounting for, like legal hurdles, like people not being giving over access to their data as trivially as, or as as easily as was possible in 2022. if we zoom out just a little bit and we look on the span of years and decades, what do you think? Yeah, how do you think these kind of those factors, along with other factors, will affect the development of more general intelligence over a longer period?
Sure. I think that right now, of course, there's a lot of interest in AI.
Hmm.
And when I talk about an AI being able to do a lot of what humans do, or take up, be better than the
Hmm.
average human in the average
Hmm.
profession,
Hmm.
I honestly think that a significant part of this is literally doing the interface work to incorporate AIs into businesses. And I think the
Yes.
metaphor that I've used with people before is I talk about self-driving cars. And self-driving cars, of course, go out and they have cameras and they have LiDAR and they have all sorts of sensors to try and pull in data from the human environment driving down the road. The really hard part for or one of the hard parts, there are many hard parts to doing self-driving car engineering, is that the environment they're operating in is really optimized for the things that humans are good at and not the things that
Right.
computers are good at. And you can
Right.
imagine if you were able to redo every single road in the world, you could have little transmitters embedded in every car, and you could give everyone phones that signal their
Yes.
position at all times. And this sort of re-engineering would make the problem of self-driving cars a lot easier. And this sort of process exists in a smaller, less serious scale in every business today, where I have to pick up the phone and call someone and have a discussion about some sort of business issue. And this isn't really captured very well in a AI's world model because, of course, this training data is not there. A lot of these models are
Mm.
trained off of things on the internet,
Mm.
and that's a lot harder for that. It's a lot harder for the AI to adopt. I can imagine a
Fascinating.
world where you have a new company that's formed that says, okay, we're AI first. And let's say you have a trucking company. And trucking company, they go out and they dispatch drivers, they make deals with companies that need to have stuff delivered, which involves calling them up saying, okay, we're going to have an order. We'll have a driver arrive at 10:10 a.m., call up the driver, say, get there at 10:10 a.m., pick up this thing, carried elsewhere. There's a lot of human interface work that doesn't
Yep.
necessarily need to be done using these human interfaces and doesn't necessarily leverage what AIs are good at, so to speak.
Yep.
Where, yeah.
Yeah, and I completely hear you on this point. I've actually, as a entrepreneur myself, I think a lot about, how do we try out using these tools in the real world, and even in my personal life, I've noticed this. Like, it is hard to create AI only workflows. It is
Hmm.
still hard to ensure that it's not just passable, but actually good enough to do the job, which is a different hurdle. So I definitely agree with you and think there could be some challenges in deploying these technologies in the sense of applications and economically
Hmm.
useful work. I guess that I would ask the question of, you know, certainly taking existing models and applying them in more parts of our economy. That's one path to AGI. There's also this kind of possibility that there's more techniques and paths to
Hmm.
AGI that we're not seeing, right? For example, for myself, I'm spending a lot of time looking at labs all around the world working on general intelligence, and the large language model is one approach, and having that be a greater part of the economy is one path that people see towards greater general intelligence being deployed, but not the only approach, right? Like, it is also possible that a research lab actually is the first to kind of create general intelligence by taking things for non-commercial purposes and developing something that ends up having quite significant capabilities. Now, I know that that's different to a little bit to the Nick Bostrom definition, because it may not. There's a question there as to how quickly that affects economically useful work, but I think more broadly, creating something that is powerful, whether in a commercial or non-commercial context, has real implications for our world, and obviously things can change from there. So I guess what I would ask is definitely looking at the underlying uh, world as we can see it narrowly in today, all of what you're saying makes a lot of sense. What are the how do we account for the broader set of people around the world, labs around the world, working on general intelligence and how those things may drive towards ever more capable systems that eventually start to resemble or look like AGI?
Certainly. Now, this is often sort of a tough question to approach because
Mm,
what I described earlier is basically a model where um, developing AGI is very capital intensive. And
hmm
in
hmm
the history of sort of scientific projects, you do have things that are very capital intensive that are sometimes really informative. I think
mm,
probably the two things I go back to are the development of the Large Hadron Collider, tremendous amount of money being poured in, and
yep,
the Manhattan Project, sort of, which I
yep,
regard as a sort of fundamentally scientific and industrial enterprise
yep,
that's very government directed, similar to a lot of labs. And
yep.
the way I think about this is I ask, what is the driving factor behind these developments? Like, what is the motivation, or what's something that requires all of these resources being to be poured in to sort of drive these scientific developments? Because I, looking at the current state of AI resource or research, it seems like it's a very resource intensive enterprise to me. Like, I don't think that we'll
hmm
get very far just by having a lot of sort of human intellectual work being done. That's a very important complement, but it's a complement to a very
Yep.
capital intensive
Yep. You also
process.
need, and we've seen that with things like GPT-3, a lot of the underlying things have been around for at least a few years, and some of the even more underlying things many decades. But it was that combined with scale and of compute and data that led to the emergent properties that we're now also excited about.
Yeah, and that's sort of what I think about. Of course, I obviously have to understand that this might be wrong, um, and
Yeah, of
that
course.
there might be somewhere out there a big technological breakthrough, or sort of, I'd say, like a scientific breakthrough that makes uh, AGI a lot easier. And
Yep.
when I think about this, you have to ask a more general question of like what's sort of the base rate of these breakthroughs in the field? And I haven't done much research on the
Mm.
specific steps, but across science in general, I have seen that these breakthroughs are fairly few and far between. And I'll
hmm
actually, I guess this is as good a time as any, sort of lay out exactly my timeline that I'm
Yeah,
thinking,
please.
because I'll take Nick Bostrom's example, Nick from Superintelligence, how he lays it out, where you say 10% chance by date X, 50%
Mm.
chance by date Y, and
Mm.
90% chance by date Z. I'll actually say that I think there's a 10% chance of AGI by 2028, and this
Okay.
10% chance incorporates either a lot of resources being poured into it very fast, your sort of Manhattan Project model, which
Mm.
accelerates progress very quickly, or there being some currently unknown scientific knowledge based advance that someone's going to figure out soon. And then once you're there, you accelerate super fast to the AGI point. 50% I'll put at about 2040. And here, my fundamental model is things keep chugging along generally how they are. Investment has its ups and downs, but it's generally consistent. And then at some point, you have incremental progress. People get better at developing world models and better at training these AIs, and you get ever closer to a sort of production AI that's able to do these sort of general intelligence tasks. And then my 90th percentile, I'll put at probably 2065. And
Mm.
in this model, you might have outcomes like a change in copyright law that makes it really, really hard to use um, text to create a worldview.
Right.
Like, we know that GPT-3 uses some web scraping. You can imagine a copyright law where the government says, okay, if you use any copyrighted text in training a model, you have to have permission of the owner. all of a sudden it's really expensive to create these corpuses that carefully exclude any text or that have the proper license agreements in place. You
Mm,
have a move towards more domain specific AIs, where, say, you're a company that employs a lot of software engineers, you start training a model based on your software engineers' work. Like, say, you have a set of tickets, a set of code changes, you try to train a model that does that specific work. It might be very effective in its specific domain, but it's not generalizable the same way other approaches might be.
yeah, yeah. Yeah, and I think firstly, thank you for sharing those three forecasts, and I think they're very sensible. I think they align with a lot of the facts and a lot of the most rigorous ways of thinking through this. You know, bear you know, regard unless there's some really huge phase change that we're not seeing, for example, a new technique. I think those types of predictions make a lot of sense. Um, and I think they're sensible ones. I guess the only thing I think about that could change those forecasts potentially, and you did touch on them, is those kind of new techniques. In particular, the area of reinforcement learning,
Mhm.
where agents are being trained in things like video games, um, and gaining capabilities in a virtual world, which may translate to planning and execution in a in the real world. Those are some interesting techniques. Not that those techniques aren't at least in some way incorporated um, into some of these things like GPT, but they're still subtle parts of that. Most of them are not agent-like movements through real world-like environments, and those are some potential techniques that kind of circumvent some of the problems that we've been talking about.
Absolutely. And I think that the model that's driving growth in AI in sort of
Mm,
my 50th percentile model is a combination of using real world corpuses, real world data to improve AI, and developing these um, sort of virtual reinforcement learning environments. The hard part is that it's extraordinarily challenging to develop a environment that covers the entire body of human interaction. I think that
mm, mm,
there are certain blind spots that I try to be cognizant about when I'm thinking about AI, where certain human intellectual tasks aren't covered that well in any training corpus, really. And I
mm,
think one example of this is when I was working in the legal field, when I was working in litigation. I
mm,
wasn't a lawyer, but I worked with lawyers, and I've seen that in the legal field you have two types of interactions. You have your very formal court documents where you have filings and arguments and testimony, and people have already tried to use GPT type models to actually improve that, to sort of create court documents, create filings, argue in court. But there's also something else, which is the lawyers' interactions with their clients that are never
mm,
recorded in any sort of training data, um, and won't be really well represented in any AI's world model because, of course, these are interactions that are privileged. These are interactions that occur on the phone or in person because when I did it, we were very sensitive about discovery. So I'd often have a phone call with someone rather than sending them an email. Um, and because of that, I see environments like these being a bit of a blind spot for a lot of these AI
yeah.
models. And I have a lot of uncertainty there about how well they can generalize into this set of intellectual tasks.
Oh, I think it's a fantastic call out, and by the way, one that hasn't come up specifically on this podcast. So it's a really important and unique insight. I think it's actually making me think about also, so the definition of AGI that we've been using in this episode is around economically useful tasks and around human tasks. But actually, it's probably, I mean, it's definitely not the only definition of AGI. And if we use a different definition, which is around just its ability to um, solve problems in still not narrow, but still defined domains. So, for example, I now could imagine, it's not a guarantee, but I could imagine, for example, us developing a machine intelligence that you can talk to and has abstract reasoning and maybe even does things like, discover new mathematical theorems and writes beautiful code better than a human or better than most humans. Um, but that still couldn't navigate the physical world if
Hmm.
it tried,
Hmm.
and this is, I think, for some people that's what they're imagining when they say AGI, and that still has really big implications for our world, potentially even from a safety perspective. Um, but it's quite different to one that can just solve all problems and go around and achieve anything at once in our world.
Yes, and I think that here is actually a useful point to bring in an analogy to human brains. Because, of course, we think of
Mm,
humans as being very intelligent in general, but really there are a lot of shortcomings that human brains have that are probably going to be very different than the shortcomings that AIs have. Like, obviously,
mm,
humans, very good at walking around, very good at seeing objects and recognizing them. But to be honest, not very good at all at like multiplying large numbers. Even I, who work with numbers professionally, find it very difficult. And I think that there's a perception when I look at sort of the popular literature that AI, when it comes, is going to be better at humans than everything. I think that a more likely outcome is that we'll enter a period where AIs and humans have a different set of skills for a period of time, and at some point, eventually, AIs will be better at humans than humans at things in general. But there will be sort of a spiky period where humans and AIs are highly complementary on their skill set. And I like that
mm,
you mentioned the idea of an AI that was good at mathematical theorems and, say, mathematical research, but very bad at interacting with the world. I think that there's a big trade off in training between, in terms of resource intensiveness, like an economic trade off between an
mm.
AI that is very domain skilled and an AI that is very generalist, to the point where when we have AI systems that are AGI, I expect they're still going to use a lot of subroutines um, that provide an interface where we can understand what they're doing, where they're using other models, rather than just being one giant model that internalizes
Right,
the entire world state, from
right.
playing chess to negotiating a business deal to predicting protein folding, for instance.
Right, right. Yeah, and I mean, when you hear these definitions include things like single model, I mean, it's a messy concept, right? I mean, is
Mhm.
it a single model if it has a little part of its neural net that's just actually really good at one thing, or yeah, I would actually change Nick Bostrom's definition to at least include the use of tools, right? Like it's not
Yes.
like of course you don't. Why would the AI choose not to use a calculator for a calculator? It wouldn't necessarily. It doesn't need to do it all in its own neural net weights. It can just use a calculator if it wants to do arithmetic and use use the mail to send something if it wants to send mail rather than invent something else for it. So these things get a little bit grayer as we start to think about how they would interact with a broader set of problems.
The metaphor I sometimes have used in talking with people previously is, say we're having discussion not in 2022 or 2023, but 1623. We're talking about the future of the Industrial Revolution and about what machines will take humans' jobs back then.
Mm,
We could easily, and I think that we'd be correct in saying that most human jobs in 1623 are now long since supplanted by machines. But at the same time, the skill set of these machines is very different from humans, and we'd enter a very difficult uh, pers- definitional problem when we ask about like what what's the boundary between machine and human and the joint machine human system.
yeah, yeah. Well, yeah, and I think you mentioned this earlier, and it did get my mind going about, you talked about kind of, our relationship with machines will change. And I was thinking, well, we're already there, right? We already
Hmm.
use narrow AIs and tools all the time in such an intense way that it's hard to even tell apart what's which. If you're an alien race looking down on humans and you see their little white things popping out of their ears. Those are AirPods. This little cube that seems to be perpetually attached to them. You can almost, it's hard to see what's what. So there's clearly that blending already happening, even if it may continue, that trend may continue and potentially accelerate over the coming decades.
Yes, absolutely.
Yeah, fascinating. Well, Ryan, that's really interesting to get your predictions and to think about some of the implications. That's been fantastic. Um, I'd love to get your perspectives on how you think these technological developments will affect our society and our world, and how you think we should be thinking about them to ensure that these developments can be as beneficial to the world as possible, so we can ensure there's something positive that we want to see in the world.
Absolutely. I think that um, the big risk with AIs is not what people sometimes talk about, which is sort of mass technological unemployment. When I look at AIs so far, what I'm seeing is very complementary to human knowledge, human skills. Like people talk about, oh, the software engineers will get out of work. I think that what we'll really see is software engineering becomes a little bit less involved with the precise details of code and more about sort of your systems architecture. We basically move of one level up in the set of abstraction.
Yep.
At the same time, I think that the big societal risk is that the development of AIs really advantages countries that already have the infrastructure to use them and deploy them easily. And when I think about AIs, I think that macro level, overall, the US is going to be just fine as a whole because internally we have systems that can redistribute the between the winners and losers. I'm really worried about places like less developed places in Africa that aren't really well networked, that all of a sudden have less favorable terms of trade in a absolute sense, even if they still have areas of comparative advantage. And the outcome in a super worldwide macro sense is that you once again see a divergence between developed industrialized countries and the rest of the world, similar to what we
Mm,
saw in the 1800s during the
I
Industrial
was going to
Revolution.
say, and yeah,
But
essentially the colonial era.
yeah, not necessarily colonization
Sure.
specifically,
But in
but
but in
the
that time period, it
in,
led
the,
to that
in that area
because
specifically.
of the technological gap.
Yeah, and exactly, and the fact that that divergence has been closing over the last 50 years, in relative terms, has really been one of the great stories of the last half century. The fact that countries like India and Bangladesh are no longer nearly as poor as they once were is fantastic news when I think about it sort of in
Absolutely.
EA, effective altruist terms. And the big societal risk that I see with AGI is that in this intermediate period, that risk is going to open up. Of course, the other thing that we can talk about with AGI is this existential risk, which is I think that there's Yudkowsky had this original scenario where AGI develops. You have a very rapid transition, a hard takeoff, where you can't control it through like regular political or human means. Things happen too fast. And I actually am not as pessimistic as someone like Yudkowsky is,
Mm,
because my mental model of the world where AGI emerges is a world where we already have domain specific AIs that are better at a lot of narrower things. And there's going to be an interface between the AGI and those narrower models that we're maybe able to better understand. I realize this is sort of a weaselly answer because I'm not making any hard predictions,
it's all
but
good.
that's
No, no, it's not. It's
what my
not. It's
thoughts are
not.
right
This show
now.
isn't just about predictions, and there's more to it than that for sure.
Oh no, it's just I guess my instinct as a forecaster is to try to give a useful forecast, and that is not
Sure.
as much of a useful forecast. That's just directionally what I'm thinking about.
Sure, sure. No, and we'll do a whole episode sequence on the risks and implications. But I will share that overall, I am actually in the same boat. I think the risks are real. They're things we should be taking seriously. We should be working on them. Um, but the scenarios around hard takeoff, where the AGI is just dramatically more powerful than us, and all these things, I think those things are far from certain and far from the way things will play out. I think we have many more kind of things to see and things to play out before we're there. So, yeah, I think I have a realistically optimistic view of that future as well.
Yes, and actually, I think that the AI outcomes that are most negative, that I'm most concerned about, are potentially not general or generalizable, or they don't involve a general AI, but rather
Mm,
an AI that's developed to be, say, very good at exploiting security vulnerabilities in computer
right,
networks.
right.
I do sometimes think that, say, a country like, I don't know, Russia, to give a hypothetical example, that has an
Mm,
investment in cybersecurity, might invest a lot of energy into developing a tool like this, which could cause a lot of chaos because it moves the cybersecurity constraint from people or people who are doing malicious stuff to something that's more driven by ability to scale up the processing power, which is maybe allows you to exploit more vulnerabilities more quickly and cause more damage if you wanted to deploy it that way.
absolutely. Oh, and the risks and challenges from narrow AIs is already a present thing, and it's almost certainly going to get more challenging. Of course, the countermeasures will also get more advanced, so we'll see how the dynamics play out. But the risks and challenges are real, and we should be working on effective countermeasures and solutions to the narrow AI type challenges as well.
Yeah.
Yeah, fantastic, Ryan. Well, we'll wrap up now only because we could talk about a lot of these things for a long time, but I think we're at a good healthy finishing point. I want to just ask Ryan, do you have any last comments, suggestions, or thoughts for our listeners? And our listeners are technical folks or people who are involved in the technology world who want to ensure that the future of artificial general intelligence is as positive and beneficial as it can be. Do you have any thoughts or recommendations for our listeners?
I think that working with technical folks in the AI world is really been informative and useful for me. And I think
Mm,
that one of the exciting things about AI is that there's so much that's currently uncertain about how it's going to develop and what tools we're going to use. And the thing I always encourage people to do is to sort of have as much epistemic humility as possible. Like, it's been great talking to you this afternoon for me, and I honestly don't have any confidence that what I've said is going to turn out to be right or not. Hopefully it does, but it's really been exciting for me to realize the limits to my knowledge. And I think that the best part about researching AI and working with AI is you get to be wrong a lot and you get to grow a lot really quickly.
right.
And that's what I encourage people to do, and to not feel like and not be discouraged when you try something or you say something and you realize later that you're totally wrong about that. Like, that's the best part of researching AI and being this field right now.
Yeah. Oh, I completely agree. I feel that every single day, multiple times a day, and I think being humble and just focusing on the fact that we are trying, enjoying that experience, enjoying that learning experience, and doing your best is the best way forward. And yeah, anybody who says they know what the future holds is honestly lying because they don't.
Yeah.
They know maybe a little bit of forecast, but that's it. That's different from knowing the future.
And the one other thing I'd say is that I always love to talk to people about AI or about other things, and that your listeners are always welcome to reach out to me at coffee@ryankupyn.com.
Awesome. And we'll put that into the show notes as well. So yeah, if you want to reach out to Ryan and chat more about this stuff, definitely reach out.
Absolutely.
Fantastic. So we'll wrap up there. In the next few episodes on the AGI show, we'll continue to speak to experts about pathways and timelines to AGI, and we'll do a synthesis episode at some point to kind of bring it all together and give our synthesized thoughts. Then we'll move over to the implications and kind of the things that happen after AGI comes about. And I would just like to say to everyone, please, if you like the show, share it with others who you think would be interested in the topics. Subscribe and keep listening. I really appreciate the feedback that's been coming in so far. Thank you, Ryan, and to our listeners, and excited to bring more of these shows in the future. Thank you, everyone.
Thanks, Roosh, for talking to me today.